Okay, so in this first question, we have the integral from 0 to 1 of x squared times e to the negative x cubed dx. Now, this is an integral that we can't do just in its present form in terms of x, because there's no way to reconcile this x squared term with this negative x cubed term up here, right? It's just too complicated. So, probably know right off the bat we need to do u-substitution, but we need to be careful how we do our u-substitution. If we just jump right into this and we say, we see this x squared term right here and we say, oh, I'll make u is equal to x squared and then du is equal to 2x dx. This isn't going to work, right? Because we try and plug stuff in, we get u is equal to, u times e to the, there's nothing to put up here now. So when you're picking a u, you have to think a little bit ahead about what your du is going to be and how you can substitute that into the equation as well, because you need both to work. You need an expression for u to plug in, and you need an expression for du that you can plug in. So instead of u is equal to x squared, let's pick u is equal to negative x cubed. That way when we plug it in, we'll end up with e to the u, which is a really easy expression to integrate. And that'll make du equal to negative 3x squared dx. So this first expression here, this is pretty easy to plug in, and then our equation for du just needs a little bit of work because we of course just want to isolate this x squared dx, since that's what we have left over here. So if we just divide both sides by negative 3, we get negative 1/3 du is equal to x squared dx. Okay, cool. So now we have something we can plug in for u, and we have something we can plug in for du. So let's go ahead and do that. Now we have the integral of e to the u times negative 1/3 du. And we can go ahead and pull out this negative 1/3 because it's a constant, so that we're just left with e to the u du inside the integral. And you'll notice that I don't have any bounds of integration up here, right? These are both blank. And the reason for that is, if I were to put 0 and 1 right here, how we do in the original problem, that would actually be wrong. Because 0 and 1 are bounds of integration when our equation is in terms of x. So having these here now when it's in terms of u is just not correct. And there's a couple ways we get around this. Whoops. One way is to just evaluate this integral for u. Then once we're done, we can plug this term up here back in so that we have it in terms of x, and then we can use our original bounds of integration. That works perfectly fine. The other way that we can do this is changing our bounds of integration so that they fit with u. So let's go ahead and do both of these. Our first way, we'll just solve for u, and then I'll plug back in for x, and we'll use our original bounds of integration. So if we just go ahead and we'll start from this. Let's see, this will be our starting point for both methods. So we'll start here. It's a pretty simple integral to do. We just have negative 1/3 e to the u is its own antiderivative. So we have this. And then here we don't know our bounds of integration, right? So we plug back in for x. We get negative 1/3 e to the negative x cubed. Now we can use our original bounds of 0 and 1. And so when we plug those in, we get this. So I like to pull out any constants when I do this, so I just focus on this e to the negative x cubed term right here. It makes things a lot simpler in my opinion. So we have e to the negative x cubed, so this will be e to the negative 1, and then minus e to the 0, which is just 1. So we're left with negative 1/3 e to the negative 1 minus 1, and then another way we could write this is 1/3 1 minus 1 over e. And that might just be a slightly cleaner way to look at this. Okay, so that's our answer. Should be correct. And that one, we just integrated in terms of u, and then substituted back in for x, and then used our original bounds of integration. The other way we could have done this is by changing our bounds of integration for u. So if you recall, we started with x equals 0 up to x equals 1, right? And then all we have to do is run these through our equation for u that we just picked earlier. So u is equal to negative x cubed. So if we just take our boundaries in terms of x and then plug them into this function, we'll end up with our boundaries in terms of u. So we go ahead and plug in x equals 1, and we get u is equal to negative 1 cubed, which is negative 1. Then you plug in 0. 0 cubed is just 0. And so we're left with these as our new bounds of integration. So now when we evaluate this integral, we have negative 1/3 e to the u from 0 to negative 1. And then when we plug this in, pull out this negative 1/3 again, just like last time, where we get e to the negative 1 minus e to the 0. E to the 0 is just 1. So we're left with negative 1/3 e to the negative 1 minus 1. And we'll rewrite this just like we did the other one. 1/3 times 1 minus 1 over e. So you see, this is the same exact answer that we got previously. So it doesn't matter which way you do it. You should get the same answer both times. It might be a good way to also check your work if you're ever unsure. So just do it both ways.